Today, we're going to be talking about database DevOps, what it means to you, and why it's important for the financial institutes. In this presentation, I'm going to be talking about best practices and a bit about some interesting cases that we had. So why do we need DevOps? Why do we need it for the database? So obviously, everybody's trying to move faster. You know, DevOps is a reality. CI/CD automation is something that has been happening for the last few years, and everybody are accelerating. So as you can see on the slide, no matter how fast you're running, you're planning to move faster, have more releases, more frequent updates to your code, to your application, to your services, to your customers, and essentially you're planning to move faster. So that is obviously something that requires infrastructure, and this is exactly where DevOps comes in and automation in general. The value that companies have been seeing is tremendous. There's a lot of great success stories and market research that show like why it's working. I'm not going to talk about the obvious stuff. You either know that or have a lot of information about this available. The problem is that in this game, the database is lagging behind pretty significantly. You have great solutions for managing infrastructure. You have great solutions for managing application code, ranging from everything like source control with Git or ticketing systems like Jira and ServiceNow, release automation solutions from open source solutions like Jenkins to the high-end solutions, the commercial ones. And it's a big world of opportunities, and you have a lot to choose from, depending on your existing infrastructure, on your preferences, etc. But it's already something very stable, very mature. The problem is that in that database world, there's not a lot of solutions, and that is because database is significantly different than application code. That means that like everything is different. The way you introduce changes, you don't replace files like you do for application code. You add incremental changes on top of consistent, persistent schema and data. Risk factors are pretty much different. You know, if you break something in your application, getting back to an older release, if you have a good process, is pretty straightforward. It's maybe scary, but it's not hard to revert. Changes on the database front may be easy sometimes, may be harder other times, may be impossible to revert in other occasions. That is because of course, the persistency. If you broke a procedure, that would be easy to fix. That's very much like code. If you drop the column and you don't have a backup or up-to-date backup, that might be irreversible. If you did something like drop an index, that may not be an issue, but if you need to rebuild it and it takes 36 hours to rebuild this because this is the main table that you holds everything, then everybody is going to be suffering in the next few days while your application is rebuilding and your database is getting ready and everything else. So obviously, database is very different than the application that you manage. And if you think about it, traditionally, you have database experts on one side and you have developers on the other side, and they didn't mix for a long time. So silos formed and expertise formed, and the people who drive the application development many times are not that into the subtleties of what it takes to do an efficient release. Database people on the other side are not part of the DevOps evolution and maybe not on modern development processes. So there's a gap here, and of course it needs to be bridged. And obviously you can see on the screen other reasons why database is actually a gap. So what do we do about this? First of all, the survey results that you see here on the screen is from an annual survey that DBmaestro is running. One of the interesting things that we see is that DBAs are yet not part of the modern DevOps process in most of the organizations. So this is from hundreds of companies. But this is a trending change. We see DBAs more and more being introduced into the modern teams, but still, it's a big siloed operation that is taking most of the time. At the other front or other side of things, on the database front, you actually need to deal with specific requirements, specific use cases, specific risks. So if for application code, you compile your code and you have the latest and greatest, you just ship it out, you put it on your servers, and that's perfect. The database, on the other front, holds the entire configuration on each copy of the database. That means that, for example, if on one copy of the database you have a certain configuration, and on another you have other configuration, that is what's usually referred to as configuration drift, your release might work on one environment and fail on another. So you might be testing your next releases, everything is working fine in your integration, QA, pre-production. You go to production and things break because production has a hotfix that nobody implemented back into the processes. Production does work, but your new code just overrid what happened. And another team is shipping something that was not in sync with that hotfix. You just lost maybe time, maybe you reverted into an older bug that is now creating damage. And a good question is, when is this going to be identified? So you can see on the screen here, again, from these hundreds of companies that participated in the survey, the different problems that are unique to the database. The biggest one, obviously, as you see here on the screen, 70% of the companies reported the configuration drift is what's breaking their deployments. And obviously, this is something that needs to be catered for. Moving forward, so I did say that database professionals are siloed from the rest of the teams. They're not really an integrated part of the DevOps team, but this has its implications because everybody is running faster, everybody's having more productivity, more frequency of releases, shipping new features faster, and changes to the application needs to come with changes to the database. You add a new feature, maybe it has a new storage, you change the logic, it needs to have certain changes to maybe procedures and views behind the scenes in the database. So a lot of time what happens is that for these application changes, you have corresponding database changes. And if you don't have an automated process for the database, what happens is that the application just speeds up, more releases, more frequent updates. And on the other side, you have people doing manual stuff, trying to match this. And actually, over the last 2.5 years, which means our 3 latest surveys, we've seen the amount of time invested in delivering either manual or semi-automated updates to the database, taking more and more of the people's time. And you can see here on the slide, moving from 22% of their time to almost double, almost 40% of the time invested in delivering database changes. Now, think about it. You would probably have to fill up maybe a ticket saying, I need to update that object, I need to add a new table, and you would wait for someone to do that. It may take him a day or two because he has a list of other things that people are asking from him. So we have a problem. On one side, we're creating a bottleneck. We're slowing the whole thing. We're slowing productivity. And on the other side, we don't have service because people are tied into the process. And of course, this is getting worse because it's at the expense of other things like security, improvements of performance, tuning, or whatever. So it's a problem that is getting harder to live with. The biggest problem on that we found out is that if you just take a manual process or a semi-automated one and just try to do it faster and faster, you end up having more problems because it's not fully repeatable. It is based on manual work. It's based on sometimes even coding. And as you can see here on the slide, it just says something that we found out from the surveys, that if you have a non-automated process and you try to pick up the frequency, you end up with more and more failures, which nobody wants, especially not on the database side of things. So if to use the saying, move fast and break things, yeah, but nobody wants to break the database. So we need to evade that pretty much at all costs. What do we do? How do we deal with that? So we need to make sure that we implement modern processes into the database world, but do that in a way that would, on one aspect of things, deal with database special requirements, security, the different ways that changes are implemented, catering for the specific problems that are relevant for the database. And on the other side, we don't want to invent new processes. We want to use proved ones. We want to use best practices that matured for DevOps and are proven to work. So this is exactly what we should be discussing here. So talking about different best practices, you can see here on the screen. I won't just read it out, but let me just mention this. Most important thing is creating a repeatable process. Creating a repeatable process enables you to have less risk going forward. If your release process is done in the same way, in the same process, and is repeated in integration, repeated in QA, into pre-production, the chances for you to succeed in production updates is much higher than if you do something for development, change it a bit for QA, change it again for maybe UAT environments, and then hopefully test it for real on production, because that's usually what's happening when you have a manual process which is not well built and everybody's like trying to do their best, but it's just not the process, it's not working well. So this is one thing, create that repeatable process. Another thing is balancing that, I mentioned the bottleneck, balancing that bottleneck and making sure that self-service can become reality. So how do we help developers use and ship changes for the database while not creating a greater risk for database deployments? Because we said it's risky. We said nobody wants to break the database, yet we're telling people that obviously has less experience with database updates, go ahead and do it yourself. So balancing this obviously requires some processes. So I'll be talking about this. I would be talking about security. I would be talking about compliance, obviously, in the next few slides. So let's go forward. So first of all, best practices. Creating a process which relies on build once, deploy many is critical. That means that you create your code once, you don't change it again, and you deploy it the same way to all the environments. If you do that and you have a problem, just like agile coding, just like CI/CD, you go back to the beginning. You revert your change from all of the relevant systems. You recode this, you fix it, you test it, and go through the whole release pipeline again. This way, you actually ensure that you don't have one-offs. You don't have snowflakes that can break potentially your production. You have a tested, repeatable process. That is critical. Relating to state-based versus migration-based deployments is also very important to the database. We actually have a great white paper about this. So if anybody is interested, feel free to go to our website and download it. It's essentially two concepts, both valid to update the database, but both flowed from a definition and don't really cover everything that should be covered. So if you're talking about state-based, that means I have the structure of the database, and I want to implement this on different databases. That may work great, but it's never repeatable, because if we remember that 75% of the companies are failing on database drifts, that means that the database is not identical between different environments. As a result, state-based would generate different changes to the database. Some of them would be just perfect and fine. Some of them, even if technically right, may create havoc because you're not expecting them to happen, and suddenly that that missing index that naively is added to production would take the whole system down for 12 hours or 5 hours or even 30 minutes. That all the CPU is just busy with the creation of the index because you didn't expect it not to be there. Okay, so state-based obviously is preventing us from having a repeatable process. On the other side of things, if you're using migration-based deployment, that means that you're using the actual scripts to transition from one state to the other. That means that, of course, the release is repeatable. You're always using the same script, but what would happen if you actually have a drifted environment? That script may fail because it's encountering a different or drifted code, so it might even break altogether. So obviously, each method has its own strengths and weaknesses, and the best practice is to use each one with its own strengths and in different parts of the process. Again, more to read about this in the white paper that we have. It's a very interesting read. Immutable packages just completes what I just said. Once you start deploying changes, you should never make changes to the way you deploy it or to the content of what you're deploying. And that completes the repeatability perspective. Moving forward, I did mention risk a few times. So just to make sure that we limit the risk, we need to make sure that we don't have drifts. That means if I'm deploying to the next environment, I want to make sure that the configuration is what I'm expecting. If it is, perfect, go forward. If it's not, we need to know about it in advance. That might be a production update pending next week. If something is not what we're expecting, we want to know about it now. Dry runs is obviously something that can contribute tremendously into limiting the amount of fixes that we do for the database. If you have to code and your code breaks and you need to revert all your changes and roll back your database, then by definition, you have an ever fluctuating state where you go forward, you go backwards, you go forward, you go backwards. If you create a classic CI process where the tested are being driven into maybe a temporary database, that means that you can always chuck that database away and repeat that from scratch, again contributing to that ever repeatable process. So if someone breaks something and if your code is not executing well, you don't care about it, you fix the code and you rerun the whole process from the beginning, knowing that you're not actually running on your real database, so you can just recreate it and retest the package as a whole. So this is these two measurements are just great to limiting the amount of surprises during releases. Now, security and policies are very, very important from a database perspective. First of all, security and compliance need to be added as early as possible into the process. Some call this DevSecOps rather than DevOps, and some don't call it anything, but try to do that. The goal is to make sure that you introduce changes in a consistent way, and security is part of that way. Security is part of that process, so you don't end up retrofitting fixes or changes and breaking the whole thing and restarting, so you don't risk rework as a significant delay and time waste and money, etc. So things to consider. Controlling like what is being done. So if a developer would say, I'm going to drop a table, is that okay? Maybe for some, yes. Maybe for some, that's the biggest like no-no, because you decided that in your insurance company, in your bank, you never drop anything, or at least not for a year, so you would rename them. Putting a policy in the automated process would catch this with like code analysis and say, no, you cannot drop a table, rename that, change that, get someone's approval, someone senior, someone who can authorize this. But just putting that a policy process in place as part of the automated process would prevent you from having to resort to emergency fixes or running to find backups or whatever. But that's just one example of rigidity or safety. What happens if your developer just didn't write the right code? He created a new table and he put in a grant so people can actually use that, but he wrote grant all. That is exposing the database from security perspective. That's a big no-no. Granting to public, granting DBA rights. That doesn't fly on production, so you shouldn't do that on any of the previous environments, again, in the same aspect of repeatability. So catching these things, making sure that you can actually evaluate changes as soon as possible is critical. And you can see other examples here on the screen. The other aspect of policies is actually managing not the content of what's being done, but who's doing it. So I mentioned self-service. Self-service is for a developer say, I need to maybe add a procedure, update the procedure, and that's great because if you automate the process, he would not have to wait for a DBA to do that manually or even to semi-automate this. But again, that's a waiting game. If you want to practice self-service and CI/CD, that would happen automatically. But again, you want to make sure that you don't do stuff that is wrong. So you want to enable the developer to push changes, but maybe just to the integration environment, maybe even to QA. But he's not responsible to pushing things all the way to production because that may be someone else. Or maybe you want to practice separation of duties. One person would create the changes, another would deploy them. And yet again, to production, it would be a third person. So making sure that roles and responsibilities are part of that process is critical. That in turn puts you in a position to limit the access of people to the actual environments. If you automate the process, if you create an automated mechanical process, that means that the person would essentially not have to have credentials to log into the database, and maybe if the whole process is automated, he doesn't have to have credentials at all because the automated process will do it on his behalf. So you end up having less direct access to the database, less users and passwords being used, and by definition, more security. You know, by the way, one of the biggest problems with hacked systems is people from the inside either doing something malicious or being led to do something with keystroke recorders that just take their password and then misuse them. So again, that would solve the problem because people would not be typing in password. The whole process would be automated. Now, we covered automation, we covered risk, we covered policies, we covered security. Obviously, we need to measure what's happening. So who introduced the change? Why was it introduced? When was it introduced? Where was it introduced? Okay, all of these things are critical, not just for the financial sector, but to anybody. If it's not for compliance and audit, it's for traceability. Once you know you have a problem in your production, and you have like the suspects because you know what changed, you're in a better position altogether to fix it. If you don't know who did what, when, and why, you're in a guessing game. So having the answers to the questions on the screen obviously puts you in a much better position to drive a safe process, which is by definition more secure, audited, and get an automated compliance report at the end just by automating the task and documented the process itself as part of the automation. So that is an easy win once you implement DevOps for databases. So I wanted to end with three nice examples of success that I think really represent and summarize everything that I've been talking about. I wouldn't mention the customers by name, but I think these are great examples. One customer started with having a release every 3 weeks. Their pain point was big releases, hundreds of scripts, DBAs having to stay overnight just to deal with that, waiting for that release to run, manually typing in, running scripts, etc. Tedious work, non-repeatable work. If you have hundreds of scripts to run, maybe you run something out of order, you have to fix it. So obviously there was a problem. I would say about 3 years later, they have over 2,000 releases a month, from one every 3 weeks to over 2,000. And that is solely for this being easy. Once the process was dialed in, then it became easy to not ship hundreds of files, but to ship a single change, to lower the impact and the risk around every change, because it's not hundreds of changes, it's just one, because it's easy to do one. So the whole, the speed went up, the risk went down, and they got out of the box everything documented. So they know who drove the change, who created it, what did the server say happened. So everything is documented, they're very happy. And you see the quote below, that is really a significant time saving, because developers are driving the change, okay? And DBAs don't need to manually introduce the changes. Another example, manual changes being created by DBAs went completely to automation. So instead of investing 4 hours creating a release and driving a release every, I don't remember how many weeks, they now have 60 releases a day. Everything is automated. The DBA is completely out of the loop. There's a single DevOps person who oversees the process, not actively, but just dealing with exceptions. And self-service. A bank running self-service for the database out of the box, happily, and everything is automated, everything is documented. Great productivity. And the last case I wanted to mention is another insurance company. I would summarize this with an easy 6 days per deployment to 15 minutes per deployment, from a completely manual process to a completely automated process. That, I think, summarizes the whole thing. It's not just productivity, it's productivity tied with security, tied with compliance, with risk management, and essentially you have nothing to lose. You can see the stories here for yourself. What does DBmaestro do? DBmaestro is a DevOps for database solution. DBmaestro drives all of the things that I've been mentioning here. So at the end of the day, it plugs into your existing processes. It plugs into your Git and Jira and Jenkins or other solutions. And on the other side, connects to your different databases and simplifies the process, encapsulates the actions, and gives you the functionality that I mentioned. That means delivering automation, preventing issues by running dry runs, adding policies and enforcing it, managing roles, creating governance reports, and essentially creating a safer process for you all. And with that, I would like to leave that to additional questions from you. Thank you.